In today's clinical research ecosystem, study design data often lives in silos. Each stage, protocol, CRF, SDTM, requires manual remapping, leading to high effort, errors, and inconsistencies. Legacy assets like Define-XML and annotated CRF hold valuable information, but without semantic tags, they're hard to reuse. Unclear protocol text and time-consuming spreadsheet-based curation make the challenge even greater. The result is high manual effort, low reusability, and inconsistent use of entities across studies. That's where biomedical concepts, or BCs, come in. BCs provide the semantic bridge across standards like USDM, CDISC, and SDTM. Zifo's aim is to transform manual curation into intelligent, agent-driven BC libraries. Zifo's commercial solution is powered by agentic automation, explainable AI, and human-in-the-loop oversight. The outcome is minimal human effort with maximum semantic consistency. Our vision is clear. Automate BC extraction from legacy study assets. Orchestrate multi-agent AI for curation and creation. Ensure explainability with full traceability of every mapping. Deliver reusable curated outputs, ready to flow downstream into CDISC libraries and sponsor workflows. Welcome to the Genesis, the gateway to intelligent biomedical concepts, curation, and creation. As a part of our vision, this app supports protocol file, ACRF, ODM, XML, and Define-XML. In this demo, the workflow is demonstrated using the Define-XML. Once the file is uploaded, you can select the target biomedical concept version. The system automatically fetches the latest available version from the CDISC Biomedical Concepts Library. Moving on to the data extraction phase, where the uploaded defined XML is validated and the file specifications are retrieved. You can see the SDTM version and the defined version. The validation is performed automatically by the agents to ensure the file structure and metadata are complete. Once the validation is done, the available SDTM class and domains are fetched. You can see the classes and the number of domains available for each class. In this video, the scope is narrowed to focus only on the finding class. You can see the number of tests for each domain in the finding class. With a test extracted from the finding class, the workflow proceeds to curation step. This curation step is fully powered by agents that automates the mapping of extracted tests to existing biomedical concepts from the latest CDISC BC Library. Mapping is driven by similarity score. If the score is greater than 80, then the test is marked as mapped. The score below 80 are flagged for review. The tests with the score below 80 are presented for the manual review. This human-in-the-loop step allows users to approve or reject the mapping. The approved tests are marked as mapped, while rejected ones are reclassified as unmapped for the further processing. Once the mappings are confirmed, the curated biomedical concepts are finalized. Each map test is linked to its corresponding BC using the BCID short name and category. The intermediate output is generated to summarize the curation results. The map to BC displays the domain, test name, BC name, synonyms, BCID, and its category. The unmapped disk contains the domain and the test name for the further processing. Moving on to the creation step, where it is automated with an agent which follows the CDISC biomedical concept creation and curation principles. It begins by searching for the matching NCIt codes with a test name through API calls. If match is found, the agent populates the fields such as BCID, short name, category, synonyms based on the guidelines. It also fetches the corresponding LOINC system code via API calls. If no match is found, the agent creates the placeholder entry using the standard BC template, ensuring compliance with the CDISC principles. You can see the example. The C new is a placeholder where the test name match is not found. Once BC creation is complete, the agent maps the data element concepts using the BCDC template. Mapping is based on the BC category domain and class. The corresponding BEC is found. It is linked using the fields like DEC ID and DEC label. If not, it searches for the NCIt suitable matches. If no match is found in the NCIt either, a placeholder DEC is created to maintain the structural consistency. Moving on to the summary part. This section provides consolidated view. It is organized into 3 tabs for the easy navigation. Curated BC concepts mapped from the existing CDISC BCS created BCS. The new concept generated using the NCIt Northern NCIt concepts for which the NCIt match is not formed. These table contains all necessary fields which are mentioned in the CDISC Biomedical Concepts latest file. Potential challenges, barriers to scale. When scaling data curation, several barriers emerge. Firstly, older protocols often rely on broad umbrella terms, like anthropometry, without explicit detail. Mapping these to biomedical concepts requires deep clinical judgment, and without human oversight, AI risks creating mappings that seem correct, but are contextually wrong. Secondly, controlled terminology alignment poses challenges. Standards like NCI and CDISC are updated regularly, And if libraries aren't synchronized, version drift can cause matched codes. Even when terms exist, multiple candidate codes create inconsistency, reducing interoperability. Thirdly, handling evolution and amendments is critical. Protocol changes or Define-XML updates must flow through the pipeline without corrupting curated libraries. Human-in-the-loop ensures continuity across versions and prevents drift. Finally, governance and compliance play a central role. Regulations demand traceable, explainable decisions. Human validation acts as a compliance checkpoint, ensuring no AI-derived output enters production unchecked. Strong governance frameworks must also guide the responsible use of AI. Together, these barriers highlight why human expertise, strong governance, and alignment with evolving standards are essential to scaling successfully.